weiterzuleiten. So now we switch to English. It's my great pleasure to introduce Dr. Ben Henson from the University College of London. He's one of the board members of the IDDSI initiative most of you know, and we are very glad to have you here, Dr. Hanson, and I think the virtual stage now is yours. Please.
Danke und guten Tag. I am sorry that this presentation on behalf of IDDSI will be in the English language. As I say, on behalf of IDDSI, we are supported by commercial sponsors. These sponsors pay for our website, our administration, but they have no control or no influence in the content of IDDSI, which is there for clinicians like yourselves. So today's presentation is about using textures in the management and diagnosis of swallowing disorders. And we start with a reminder that IDDSI has been created to be used by all ages, all care settings, and to be applicable to all cultures around the world. It was set up with the aim of removing these language barriers which are subjective and vague. And instead we wanted to create more precise control of textures so that they could be better understood. In other situations, we have precise measurement and control over quantities. But when we came to defining how thick is thick, it was a bit more of a challenge. And now I will present some of the science behind that. The context is swallowing, and we want to really understand what happens when a fluid or semi-solid is swallowed. We can use video fluoroscopy, of course, for that, but I want to consider the process being an interaction. We have an interaction between sensors, control, and of course the bolus itself, which is purely passive. The bolus can't control its motion, but by choosing the mechanical properties, the texture of that bolus, we can control the relationship between force applied and movement. And so let's consider gravity, shown by these arrows acting on the bolus. The bolus is also under the action of forces from the tongue and palate. As the bolus moves, it creates forces on the tongue and palate, which are sensed. And thus we have this cycle where the sensation and control are linked with the bolus in the middle. And that needs to be controlled to propel the bolus posteriorly through the pharynx, past the larynx, and to the esophagus. Now, how to measure that in vivo is extremely difficult, and we have to rely instead upon lab-based simulations. And this is the one that I have in London, where we have a simulation of a soft tongue with controlled motion, and using visual and pressure sensors, we can measure the flow and the pressure causing that, and the relationship between pressure and flow, so that for a particular type of fluid, we can start to identify how that might behave in a mouth. Now, when IDDSI looked at creating standards and measurements for textures, we started with a systematic review. This was in 2015, looking for evidence relating texture, thickness of liquids, to clinical outcomes. And we found plenty of publications, but not very much evidence quantitatively linking texture to a clinical outcome. What we did see, though, was that thickened liquids tended to help people who aspirate thin liquids otherwise. Notice that it just says thickened we don't have quantification yet. We also found that there was evidence of liquids being too thick, where they caused residue to accumulate, and that could then be later aspirated. Plus, very thick drinks are not appealing, and so the consumption volume would decrease. So we need to find more evidence, and this is where IDDSI can help by creating a standard set of stimuli that people can now use in research. At the time, there were lots of ways of measuring material properties of liquids, but they didn't match to each other, and so we couldn't create a pyramid or a tower of evidence. Each piece of evidence was separate. So what we needed from the point of view of IDDSI was a way of creating a measurement that can be used in a number of different settings, in the lab and also in the hospital and in the kitchen and at the bedside. Starting by looking at the most scientific measurement, using a viscometer to measure viscosity, well, we found a number of disadvantages. Firstly, this does not look like a mouth. But secondly, and more importantly, viscosity is too simple of a measurement to quantify foods and drinks that we normally eat and drink, because they are non-Newtonian, which means that to characterize a product, you need to take many, many measurements over a wide range of test conditions. One individual measurement on its own does not describe whether one particular fluid is thicker or thinner than another one. So that has a number of disadvantages. We looked at a spectrum of measurements from very simple and not very accurate to much more accurate measurements, but those which would not be useful by the patient's bedside. And we settled in the middle, where we used evidence from the laboratory to create a tool which can be used by a wide range of people. We looked at some other existing practical measurements, and we chose the syringe flow test, which I'll show you in a minute, because it represents, as well as we could, the flow in vivo, which includes shear motion, flow, but also extension of the liquid as it's swallowed. So this is the test that we chose, and I hope you will have seen this by now, where fluid flowing through a 10 milliliter syringe will flow faster if it is thinner, and by stopping at 10 seconds you can get a number which represents on a linear scale how thick that liquid is. Now, this is not one measurement of viscosity for the reasons I described, but it can quantify in a relatively physiologically relevant way how thick the fluid is and how fast or slowly it will flow. Also, by observing the flow in a range of different liquids, you can get a visual impression as well, from streaming through to slow dripping. So this provides another way of comparing a simple measure of flow. And here's the science behind that. We conducted an experiment using a computational fluid simulation of the flow within the syringe, which we cannot measure otherwise. And we combined that with measurements of a variety of different liquids, so that we could verify that the types of flow observed within the syringe were as representative as possible to the types of flow that had been measured in vivo. It's worth saying, though, that in vivo measurements still need to improve a lot. So we do have some measurements of Newtonian liquids as well as starch and gum thickened liquids within the syringe. One moment. IDDSI would like me to remind you to use the correct syringe because it's vitally important that you have the right dimensions. And in Europe, that is the BD 305959. In the future, we hope that IDDSI funnels will be available. And at the moment, we are producing these as prototypes, which we are going to test. And then hopefully these will be available across the world by the end of the year. When we looked at the relationship between solid foods and swallowing performance, there was even less evidence, mainly because of the risks associated with studying swallowing in difficult or dangerous conditions, where death by choking would be a reasonably likely outcome of that study. So instead, we looked at autopsy data post-mortem and investigated materials which had caused death by choking. And we identified a range of properties such as stringy, crunchy, crumbly, which could cause an increased risk of choking, and these were to be avoided in a dysphagia diet. We also looked at anatomical dimensions so that we could choose particle sizes which would minimize the risk of choking, so that particles would not become blocked in the trachea. The number of levels of categorizing foods was chosen to match the natural oral processing behavior, where we break down foods into a material bolus that's easy to swallow. And so these stages correspond to the properties of teeth, tongue, and tongue propulsion to swallow materials. We would take a bite to reduce the particle size, chew the bolus with teeth or even with the gums, and mash that with saliva so that we arrive at a bolus with small particles which is comfortable to swallow. Some materials don't have any particles at all. If that material is smooth and moist and is not sticky, then you can swallow that with no oral processing. So this would be suitable for the very most limited capabilities of some patients. So these levels, all in all, created the IDDSI levels for food. Now, when it came to measuring soft and defining soft, again, we used laboratory-based instruments to take some measurements, but we needed to create a tool that was useful by the patient's bedside. And so we arrived at using a standard fork and a measurement of pressure based on whether your thumb blanches. So if you can see this, we have some banana here, and I would apply a pressure so that my thumbnail will blanch. Difficult to demonstrate. But the pressure there is roughly equivalent to systolic blood pressure, and that is relevant to pressures within the mouth created by the tongue against the palate for swallowing comfortably soft foods. So that is a way of replicating that laboratory instrument test by the bedside. Now, a final point is that using these measurements in practice, IDDSI is a language for communicating diagnosis and therapy strategies, but it is not a law. So it should be used as a tool for communicating, not a textbook for how to treat a certain type of dysphagia. Instead, clinical judgment, your judgment, remains the top priority, and you should have control of the textures that you want to apply across the patient's care. A further benefit of IDDSI is that it can give you a quantitative measure of a patient's capability. For example, in the recent Dysphagia Research Society meeting, virtually, we had some papers describing the functional diet scale, where rehabilitation was quantified based on the IDDSI levels consumed by a patient. IDDSI can also be useful for auditing or research, so that now we create a body of evidence which can be used collaboratively. So appropriate use of measurements is a cornerstone of IDDSI, and I say thank you for your attention and for listening, and I can be contacted at these addresses. Thank you.
Thank you so much. Thank you so much, Dr. Hanson, for this really brilliant talk. Are there any questions? Please write them in the chat, also in German. We would translate your questions. There's one question, just a second. How would you classify mixed consistencies like kiwi smoothly defined by the pits or by the fluids?
Okay, this is an important question, and part of the IDDSI framework is that the textures that we define on the pyramid here usually exclude pips and seeds and mixed textures like that, because they are an extra challenge. So they would correspond to the most difficult level of swallowing, which would require a normal healthy swallow to cope with, not usually suitable for somebody with dysphagia. There are many other examples of fruits, vegetables, and bread, for example, which are usually excluded from dysphagia diets.
So, no more questions as far as I see. So we have to proceed due to time reasons. Thank you so much, Dr. Hanson, for this brilliant talk. And now I give over to my co-chair, Karl Hörmann.
Ja, und ich darf den Herrn Solereder